Welcome! In today's video, I'll be demonstrating Codeware's compressed software for ASME Section 8 equipment. The goal of today's video is to see how Compress can help you. So whether you're looking to increase productivity through faster modeling, calculation, and report generation, or if you're just looking for a double check of the ASME codes during the design process, Compress may be a great tool for you. Now let's get started by creating a new piece of equipment in Compress. I'm going to go to the top left hand side of the screen and select File New. And from here I can select either a pressure vessel or a shell and tube style heat exchanger. Now in this example we'll be focused on just our Division 1 vessel here. So I'll select that file, and here we'll be able to create that new document where we have our modeling space here in the center, our specification sheet here on the left hand side, and this is where we'll enter in general information for things like the location, purchaser, PO numbers. For those of you that are working with existing equipment, you could also include tag numbers or add additional information. Maybe if you want to include a reference to a P&ID, you can add additional information here that's all stored within the file. From there, we'll select our code requirements. So within Compress, you do have two modes to operate the software in, and the first is design mode. And design mode is going to turn on a tool that will automatically increase thicknesses for components based on your design requirements down below. In some cases, you may be analyzing an existing piece of equipment, and for that we have rating mode. So rating mode will turn off that automatic thickness increase in design mode and allow you to run your calculations based on the thickness that you've entered. For this example, I'll focus on design mode. And of course, we can also change units at any time when we're working with the software. So whether we're going to work with US customary or SI units. We can also change divisions as well. So this makes it easy if we're going to compare two designs, Division 1 versus Division 2. We can simply do that by changing the division. Now, I will note that Division 2 is going to be specifically Part 4, Design by Rule. Now, within our software, we'll also be keeping up to date with the latest code editions. In this case, we're showing you 2021. As well as previous editions going back to 1995. For our loading conditions, we'll also be able to consider wind and seismic codes. So within our codes menu at the top, you'll be able to include a wind or seismic code using the menu here. So we can choose from the ASCE, IBC, NBC Canada, or UBC, as well as the user defined option. And when we add in our seismic codes here, we'll be able to see that we've included our wind and seismic loadings here in our top menu. Next, we'll select the orientation of the vessel. Of course, you can always change this up until you add your supports. So we can create either a vertical or horizontal vessel. Now, moving on to our design requirements, this is where we're going to start selecting things like the materials that we're using, the diameter and operating conditions as far as pressure and temperature. And starting with our material scheme, these are going to be just general selections for your material. So it's kind of the default material that's selected for each component. You can create your own material schemes. For this example, I'll just be using carbon steel. We can also enter in our inner diameter. You do have the ability to change this to outer diameter if you'd like within the option menu. And for our internal pressure and temperature, we'll be able to enter those values here. Now with the external pressure, if you're working on a piece of equipment that does not have an external pressure condition or a vacuum condition, you can set this value equal to 0. And those calculations will be excluded from the report. One thing that's also nice I should note here is with all of these inputs, if you do enter an input in a different unit, such as Celsius, the software will automatically make that conversion for you. We can also include our corrosion allowance. So here we can enter corrosion allowance for the inside or outside surface, and this thickness will just be added to the required thicknesses that we calculate. All right, so next we'll look at our minimum design metal temperature. And if we have any cladding, we can add that thickness here, as well as define some of our hydro test conditions. So if we're working with a hydro or pneumatic test, we can select those options here, as well as define if we're working with an existing vessel that's in the field, we can also select a corroded condition to consider as well. Now, once we've defined all this information in our specification sheet, we'll now be able to start building our model here. So I'll do that by using the components on the right-hand side of the screen, where you can choose from items such as cylinders, transitions, different types of heads and covers, as well as different supports that will be available once we get a little further in our design. But I'll start by adding in our first cylinder, and that will simply place that first cylinder in our model. And from here, I can double click, and that will bring us to our component menu, where we can change the name, the identifier for this component. We can adjust our material. Now you can see, since we selected carbon steel, we've defaulted to a carbon steel material. And you'll be able to select from other materials in this list. However, if you don't see the material that you're looking for, you can click Add Material and search this list using your specification number and the search bar at the top. We can also look at additional information about the material that we've selected by selecting Material Properties. And here we'll see our allowable stress at different temperatures, as well as the notes from Section 2D. Now the software's already carried over our design conditions for us here, so we don't have to re-enter those values. And we also have some options that we can select for our materials. So in this material options, you can choose whether impact tests have been performed, if the material has been normalized and produced fine-grained practice, or maybe post-weld heat treated. We can select all those items, as well as the ability to use Appendix 46. So what this will do is allow us to use the Division 2 rules for the calculations, but the Division 1 allowable stresses. From there, we'll select the type of radiography for each of our joints. And on the next page, we'll be able to enter in our geometry. So here we can select our diameter, whether it's from the inside or the outside, as well as the overall length and thickness. Now, next to our input, you'll be able to see here the minimum thickness required by code. This is something that Compress does that helps you quickly understand what the minimum thickness requirement for this component is. And you'll be able to see more details for that calculation in this details window here, where we can see in this case that our internal pressure is governing. We can also see the thickness required for external pressure, as well as additional calculations such as your MAWP and MDMT. Because we're using design mode, if I try to enter a value below this minimum thickness, the software is automatically going to bump me up. However, if I do want to increase the thickness over that value, the software will also update me on those calculations as well. So this tool can help you make faster decisions earlier in the design process. So I'm going to click OK. And now we can add additional components if we'd like. So if we want to add an additional cylinder, I can simply select and then select the location. So it's very easy to build the model. The software will guide you where you can place the next component. We can also add in a couple of different types of heads. I'll select our ellipsoidal 2-to-1 head for the top and the bottom, as well as our supports. So we could simply add supports down here at the bottom, but I'll show you. We do have the ability to add components and supports from this menu up here at the top. So if you're working with a vertical vessel, you could select legs or lugs or a support skirt. You can also attach shipping saddles as well. And then for your horizontal vessels, you'll be able to include saddles. For this example, I'll add a support skirt here, and we'll do that by simply entering in the free end or bottom diameter and the length. And I can use my scroll wheel to change this value as well. All right, so next we'll add in some loads. So under my loads menu here at the top, I'll be able to add a lateral force or a vertical load. And these are going to be point loads that are going to be transmitted down to our supports. I can also add a liquid level to consider the weight of the fluid as well as the hydrostatic head. So here we can start by selecting the height of the fluid. We can also just fill it to the height of the chamber. I can manually enter that value as well as specify the specific gravity for my operating fluid. So you'll notice now that the software has added in this line and blue disc to indicate my liquid level visually. We can also now go in and add any nozzles that we have. So I can do that by either selecting my detailed nozzle design or simply select F2 on the keyboard and then use the scroll wheel to change different sizes of nozzles. So maybe I have one on the head. And then I can go in and double click. And here I can start by changing the style. So whether I have a uniform thickness, such as a pipe, a variable thickness or heavy barreled forging, coupling, studding outlet, or long weld neck flange, as well as elliptical manways, I can select from those different styles. I can also select how the nozzle is attached. So is it set in, set on, or in some cases intermediate or Q-lip or insert lip. I can also define if it's an access opening or not. Now, with the nozzle menu, you'll also go through some items that we saw earlier, such as the material and material options. There's also a standard lookup for standard nozzle sizes, so we could increase this nozzle maybe to a 8-inch schedule 40, and that will select our dimensions for us. Down here at the bottom, we can enter in the orientation, so whether our nozzle is perpendicular or hillside. And with that, we can also enter in our location. So the offset from the circumferential seam, the angular position and distance from the center. You can also select your projection from the outside surface as well. All right, next we'll have our area of replacement. So here we'll be looking at UG37 to see the area required by code versus the area available with our current design. And here we'll also be able to see the minimum weld sizes required. So I can start by adding some internal projection to try to meet the area of replacement that's required. And you'll see that that value will update live. Now, of course, if we want to try a reinforcing pad, we can do that as well. Maybe I'll start with a 2-inch and a 1/2 inch, and it looks like that's going to meet our requirements. So you can see how having the ability to quickly iterate through different designs can allow you to, find that optimal design. You'll even notice that these values here for my pad width and thickness will help you with your design as well. So if I increase the width of this pad, you'll notice that my thickness has decreased as well. So I could reduce this to maybe 3/8 of an inch. And if I reduce this down to my 2-inch pad, I'm no longer passing and I can bump it back up to a 1/2 inch. So you can see how this tool can quickly help you iterate through some different designs, as well as make sure that you're meeting your weld sizes that are required. Now for our nozzle, we can also add a nozzle connection using this dialog as well. We can also add it a little bit later, which is what I'm going to do in this case. But I do want to touch on the WRC local stress tool. And this tool uses the Welding Research Council Bulletin 537 to look at the local stress in the shell. So what we'll do is start by entering in our radial load and bending moment and shear forces as they're defined in the bulletin, and the software will start calculating our stresses. So we'll be able to see if our stresses are above the allowable. We also include standard nozzle loadings from API 660 as well. You can also create your own data sets to use here as a reference, and those will be found in the drop-down arrow once you create them. All right, so now I'm going to click OK, and we'll be able to see our nozzle here. We can always go in and make additional changes if we want to move the nozzle in towards the center. And we'll see how that updates our requirement. Maybe we can, reduce that nozzle pad. I can also copy and paste this nozzle to other locations on the vessel as well as add some connections. So if I want to use a standard flange, a reducer, or elbow, I can attach those components as well. And you can even change the style here. Now, at any point that you want to review the calculations, all you have to do is hit F3. One thing that's nice about Compress is you don't have to go through the complete design like we did here if you do want to model a single component. Now, within the report, you'll have your cover page here and a breakdown on the left-hand side of all the different sections of the report that you can review. Now, I want to first start with our deficiency summary here. And this is where we're going to see any potential issues that we have with our calculations. So the top section, these are going to be considered our critical items. And then below that, we'll have our warning summary. And these are going to be considered less critical. Your warning summary is typically going to involve items that are good engineering practices, assumptions that the software is making, or items that may need to be considered outside of Compress. Where your deficiencies at the top are typically going to be very code specific, and you do have the ability to review those calculations by simply selecting the blue hyperlink. So as you can see here, it'll bring you straight to the component where we'll be able to see the information about the specific component, and then scrolling down, we'll be able to see our calculations down here below. You'll also notice that there'll be a reference to the code paragraph and the equations used. So auditing and reviewing these calculations with your AI will be very simple. There's also some additional reports that I want to point out that can be very helpful. The first is going to be your pressure summary. So this tool is a great way to see which component is limiting your design. So you can quickly go through your MAWP list and determine which component might be limiting that design. All right, so another important summary is going to be your setting summary. Here you'll see some important information, including your code cases and interpretations that have been used, as well as your UG22 loadings. Now, for your interpretations, within the codes menu, we do have the ability to turn those on and off. An additional item that I want to touch on is our forms. So if I go to forms here, I can select between some repair forms from the MBIC as well as our A forms from Division 2 or our U forms from Division 1. And in this example, I'll just show you a quick U1A. And what's nice about utilizing the forms within Compress, you can use your default profile to automatically complete some of the information here at the top. But not only that, we'll start pulling information from the Compress file as well. So information such as the material, thicknesses, and lengths of some of the components, such as the shell, heads. Will also help you create your nozzle tables as well that you can see here. Now, you and your AI can add in any additional remarks if you'd like, and then generate this as a PDF. Now, of course, some of you are going to be filing this document electronically. If you go back to your forms and you select Manage Forms, you'll be able to see the form that we just created. Now all you have to do is make sure the form is complete, you have your national board number, and then when you select Submit Electronically, you'll be able to save that file in the correct format to upload directly to the national board. I have one more item that I want to touch on. For those of you creating 3D models, you'll notice here at the top of your screen this solid model export. Compress does have the ability to export 3D files, and this will include ASIS, Granite, IGES, STEP, and Parasolids. We also have one more file called the Codeware XML 3D file, and this file can be used with our Codeware interface, which allows you to directly connect with Inventor. What we'll do is take the information in Compress and recreate the parts and assemblies native to Inventor. So this can be really helpful for fabricators that need 3D models and manufacturing drawings. This same file can also be used in Shop Floor, which is our cloud-based welding management software. So by using this file, you can import that directly into Shop Floor, where we'll automatically create a list of all the joints, and you can easily assign welders and WPSs to each of those joints. Thank you for watching this demonstration of Compress. If you have any questions or if you'd like to see a personalized demonstration, please feel free to give us a call at area code 941-927-2670, or you can email sales@codeware.com. Thank you for watching, and we hope you have a great day.